Hello, and welcome to FODES, the Future of Design and Engineering Software podcast. My name is Rupinder Tara. On this show, we will have guests that will discuss tools and technology that engineers will find interesting and useful. My guest today is Uzair Sayid. Uzair is the founder and CEO of NexCAD.ai, which has a very specialized but useful task of checking engineering drawings.
How are you?
Very good,
Let
thanks. Welcome to the show.
Thank you very much for inviting me, to be honest. Yeah, pretty
Yeah.
excited for this.
Oh, this, yeah. And thanks for staying around late. I understand you're in the UK, London, I believe.
It is, yeah. It's not late, it's just evening, 5 o'clock.
6
So,
p.m.
yeah,
Oh,
pretty fine.
well, I'm probably keeping you from dinner, so yeah. I used to live in England
Oh,
in London actually for 3 years early in my childhood.
oh, wow. Okay. Where
Uh,
do you remember the borough where you lived, or
I lived in Ealing.
Ealing? Yeah, yeah,
Where are
yeah.
you?
Pretty. So I'm just outskirts of London.
Uh-huh.
It's called Bedford.
It was not cool to be Indian or
Oh yeah.
Pakistani in that time. It was in the 1960s. And
All
yeah,
right.
yeah,
Okay.
yeah.
Where
Before
where
you
where before I was born, or
before you were
and
born. You're lucky to go there when you did. So what you moved there from Pakistan, correct?
yes, yes. So I
Okay.
came in 2008 for my degree, my master's degree,
Uh,
and then yeah, so
yeah.
like the place, obviously, and then stayed here forever, I guess.
Why not? They have good Indian food just like home, right? So why
Oh
not?
yeah, pretty decent. And to be honest, the quality is gone really good now. Um, I I mean, obviously, if you live for like 10, 15 years in a country, you kind of like the food anyway.
Back then the food wasn't so good, but it was, efficient chips.
Oh yeah,
They didn't have the Indian
biryani or
food is
curry.
just what Indians ate, right? So all right. So thanks for telling me getting on to telling me more about the product. You have a very interesting application. You check drawings. Your
Yes,
XCAD AI checks drawings, correct?
it is very
Yeah.
correct. Very
How'd you
simple.
arrive at this idea? Tell me what happened. How did you get into startups,
Uh,
and how did you think this was a good idea? Which it is, but go ahead. Tell me in your
so
words.
like obviously my background is in mechanical. I did my master's, which I came for from Pakistan to here in CAD.
Yeah.
So I learned everything about CAD. And then yeah, and then for like a decade basically, I worked for different companies, big companies, Fortune 500 companies. And as an engineer, like obviously I want to work on like solving real problem, figuring out new materials, figuring out why things fail, and physics and all that. But I think the problem that I encountered in across all the companies was like, okay, we were wasting time on like documentation or boring Excel sheet. Sometimes it's pretty annoying. Like you are even copying bomb from SolidWorks to Excel, and then from Excel to ERP, and like, guys, come on, this is
Yeah.
not what we studied for. So the frustration was always there, right? So and um and in 2024, I started playing with AI, and I always wanted to get into startups, to be honest. And I thought, you know what, this is the right time where it's level playing field for everybody. Nobody is 10 years ahead,
Right.
so let's just tinker with stuff. So I started playing with like little automation, what can be achieved with AI. And obviously back then the accuracy was not there, but it kind of gave me the confidence that look, there are a couple of workflows even in my past life or my past company experience that we can definitely automate with AI, right? And then I list down all the workflows in my personal life. Like, look, this is pretty annoying. I was spending that much time here, that much time here, because I gone through from a very graduate engineer to senior engineer. So I kind of knew the whole process, even project managing like multi-million dollar
Mhm.
projects. Um, so I list down all the workflows and I'm like, you know what, drafting. Oh man, I mean, I as an engineer, I love 3D modeling, but I hate doing the 2D drawings, right? So I said like,
Same thing.
somebody,
Same thing.
exactly,
Yeah. Who wants to
somebody got to
draw?
automate it, right? So there were companies that kind of started doing the automation. And I thought, you know what, this always plays for a good player as well. So I started with automation of drawing, 2D drawings. Then we had some design partners, really good companies. And then once I got involved and looking from outside, because I was thinking like, okay, I am an engineer, what do I need? But now that I'm building a company, I'm looking from outside to these company. I'm like, okay, w- every week we do meetings, we figure out, okay, the even bigger problem is in the drawing checking, right? So they waste a lot of time even to find a tolerance from a data sheet from a third party suppliers. Engineers spend half an hour, 1 hour figuring out where which spec to use, right? And then putting that tolerance in there. And then if he's a junior engineer, he won't have that confidence to put the right tolerance, right? So that I saw firsthand, from outside now, and I thought, you know what, this is the area that I want to first automate. So that's how Drawing Checker was born.
Okay, got it, got it. Interesting. So good idea. Now what? You have a good idea, but now you have to get some funding. You have to start a company, right? So you did that was a new thing for you. You didn't do
That
that
was
before.
pretty new. That was
Okay.
pretty new. So the first thing that I didn't knew anything about the startups world. So this is me as an engineer quitting my job, and I'm like, you know what? In 2025, I will go all in, right? So in January
Uh,
2025, I
So what
went
did
to San
your I
Francisco.
have to ask you what did your are you married?
I am married. I have 3 kids.
So you have to
So it
marry.
was it was
What did
not an
your
easy
wife say
decision,
about
man.
this?
Oh my God, I still try to get her on board. Like she's on board, but it's like every time, okay,
I
you
know
know.
I know I think I know. I don't know your wife, of course, but I would think that she would say, "Wait, I married you for because you were an
Exactly,
engineer, and now you just quit your job, and you're going to do what?"
exactly. And that's like obviously wife from Pakistan, like very conservative mindset. Like we got stable income, we got a house, we got a nice car. What else do you need in life? I'm like, no, I need a bigger purpose, right? I need something bigger, and I can't just because I can see other people doing, and I can't really bottle it up in myself. Like, look, why not me, right? So,
Yeah,
and I said, look to my wife, right? Look, here's 2 years salary, here's
yeah.
2 years saving. Let me just do whatever I want to do in 2 years, right?
Okay, give me
So
two
that's how
years.
I got her on board.
I see, I see. How as now it's only been 1 year since you started, right? Less than a year. You
It's
just started
yes,
earlier
yes.
than this. Okay.
It's I we actually I started. So I went to San Francisco in end of Jan
Oh,
for an
that's where I
event.
live. Okay.
Yeah,
Oh.
yeah. So there is an event called Alif, run by Umar. It's quite like famous in the Muslim world. So I
Hmm.
thought, you know what, let's just use it as an excuse, go out there, see the stuff, right? So
Yeah.
what's on about startup? So went there, did that, and then luckily I get into Founders Inc. They have like a 2 year week sprint, something that was going on. So I just said, you know, guys, please let me in. That's another story. Like I just messaged them so many times that they said, okay, yeah, man, come on. We don't know anything about you, but yeah, fair enough. Uh, so that was the start of kind of the startup, and then there, when I looked around, all these young people doing so like really good stuff, and I thought, you know what, I need to do it full time. Can't just be half here, half there. So when I came back home, I told my wife all that story. Like, look, let me just do this for 2 years.
Okay.
So
You still got a little time left. This is good. And hopefully you still have some money. Did you get some funding and investment then from
yeah, it's pretty like I was offered investment, but at that time I was because this was so new for me, and I was like, man, I don't want to take anybody's money until I am like, because coming from an engineer's background, we don't want to, take risk on, especially on somebody else's money. So that was my mindset.
uh,
I was naive, I know, but I wanted to have confidence in my like my product, and then so yeah, so I mean, for like now, I think we've done pretty well. Uh, haven't raised the money yet, but we got funding from UK government, which kind of supported us. Um, and then yeah, and now the
okay.
product we launched product in mid October, and yeah, it's going pretty well to be honest.
It's launched. It's
Oh, it's launched.
and
Yeah, yeah, it's launched mid October, and we're already. I don't want to say, but we are already like default alive in a sense because we made enough sales. money in
Hmm.
the bank, as in like so. That puts my wife to rest as well. Like, look,
Yeah.
hopefully in 1 year I achieve whatever you wanted in 2 years. So you know,
She's a little bit relieved, I imagine. Okay, good. Now it said you've already checked 2,500 drawings. Is that still a good number, or is it going up every day?
it's going up every day. We get around. So last, I think I put a tweet as well. So last week we did 1,082 drawing checks.
Hmm,
So it's roughly 50 per engineer or something like. Yeah. So the people who are using it, and we made a conscious decision as well. Like we don't give out the software for free, because the mistake that I did previously was we gave the software for free. People use it, didn't like the output because obviously AI was new at that time, and they just left it there, right? But this time we kind of learned from our mistakes and we said, until you pay, then you use it, because then they use and then they give us feedback, right? They give us
that's good. They
like this is
say
not working, and
in this country,
exactly.
they say they have some skin in the game. Like I said, it's very niche, but it's very useful. Uh, and how do you, I have to ask a general question first. It's almost a philosophical question. Didn't you think like drawings are eventually going to go away, and then you're fixing a problem that may not longer exist?
Yeah, I mean, I thought about it,
Yeah.
and definitely, I think the drawings, in one way or another, they're
Mhm.
gonna stay there for at least next 10 years.
Okay.
Because let's say even if you're not drafting, the quality checking, the basically the drawing is or is still considered as a sacred kind of contract between the manufacturer or a designer, right?
Right.
And I think it's not gonna going away at least in the next 5 to 10 years. But
Okay.
I get your point, and the reason I'm doing this is so that we can eliminate the drawings, right? So if they go away, that's even better, right? Because the next thing, obviously, the next thing that we want to automate is the drawing creation bit. So the drawing is created by AI, the drawing is checked by AI, and me as an engineer, I just look at it and approve the drawing, right,
Mhm.
and send it to manufacturer. But from the checking perspective, we definitely need to check the 3D modeling as well, right? So we if we can catch errors at even the start point, then that's even better, right? So we put like model based dimensioning that's coming still. I would say if like survey 50 companies that are around me, or they're even using the AI checker, they're not using MBT, right? So it's
Mhm.
pretty new concept. It takes a lot of time to kind of put the dimension on the model itself than to create the drawing, right? So kind of negates, but I think or this is my hope that we move this forward to the 3D model, so we don't really need the 2D drawings.
Okay.
Or actually everything is automated, like we creating the 2D drawing automation, 2D drawing checking automation, then you're just making good models, right? Or even
Right.
you don't need to do modeling, to be honest. That is even though I enjoy modeling it, but I think that's still a waste of time, of an engineer's time, right? You should be just
Right.
making decision, right? Apply this material, let's see what the simulation results are, can we can we make this thicker, all these design decisions. That's what I'm like interested in.
Hmm. Okay, so after the more successful you are, the more likely that you won't need a drawing checker because drawings will go away. Sounds like you have a plan what you're going to do next. Like you could check the model, you could check for compliance, you could do other things,
Oh
right?
yeah,
So,
yeah. I
okay.
have all these workflows that I want to kind of get rid of from an engineer's life. And yeah, pretty
Yeah.
much like 3D modeling. You don't need to do 3D modeling as well. As an
Yeah,
engineer,
yeah.
you wanna make decisions, just top level decision and critical decision that will actually make the product better. Why we choose this material instead of this material,
Right,
that
right.
thickness versus that thickness.
How does it work? I submit a drawing, but how do you take care of people's concern that their drawing is going to leave the building and is your service secure?
We are local, so we made the local software which kind of runs like their own CAD software and integrates with their SolidWorks. Well, we have two integration at the moment, which is SolidWorks and Inventor.
Hmm.
So even giving them that kind of environment which is familiar to them, not going on the cloud, gives them that confidence that look, okay, nothing is going, or we're not taking any information away from them. And how we protect them is obviously we strip down any proprietary information, or this drawing is attached to this company. We kind of strip that out, um, and also, yeah, I mean, we are not sending all the information anyway. Like we are trying to solve this with traditional computer vision and
Hmm.
algorithms. then using AI. So let's say, I mean, eventually the balance will flip, but until the AI gets really good, uh, we're trying to solve it with the normal computer vision, segmentation, OCR, and all those good
Hmm.
techniques. So I would say 20% AI maybe.
Right. From your experience, it looks like you have a varied experience in engineering. I'll say hardcore engineering, but you also had to learn a lot of programming, a lot of coding. Did you taught yourself how to use, what are you using, Python or C++?
Oh, it's
Or,
as a kid, to be honest, like um, I was really interested in. I should have gone in programming, but I went to mechanical, just because of my father. Like how things are in like back home. You gotta
yeah,
study doctor, engineer. Software was not considered at that
I
time.
know, I know.
So I was always interested in software, and even like in my engineering degree, like in my bachelor's, I was taking software courses. I was doing assignments for my my seniors who were in the software, who were studying software. I'm like, come on guys, give me your assignment, I just love to do it. Right? So that's kind of my background. So officially I am a mechanical engineer, but I used to do so many assignments for software, that I was really good at it.
So in your heart, you're a developer. You're masquerading as an engineer then. It's very interesting.
Exactly.
Very interesting. All right, so
And
I'm very
I never
curious.
knew that's gonna come to use this skill like after 15 years or something.
There was a time where they said software is going to eat everybody's lunch, and it was everything was software. Mechanical engineers, who needs them, right? They just work on little nuts and bolts and gears and things like that, right? That's all going to
Exactly.
be replaced by software programs. You want to show me how it works? I'm very curious because
Oh
I
yeah,
tell
why
you
not?
what, I had for 30 years, some years ago, 40 years ago, I started as an engineering intern, and
Oh
all I
wow.
did was make drawings. And we had a person who would uh, who would check all my drawings, and I used to live in fear of that person. You know that
Oh,
it would.
oh yeah, this is such a, yeah. I mean, I'm not gonna name the company, but when I joined, uh, I was so scared as well. Like the guy who's the checker, he looks at my drawing and you know he's gonna bully me. I was like, no way, I'm so scared. All right,
Yeah.
let's do a thing. Now that you said that like look, as an engineer, even it takes us a lot of time to figure out what's wrong with this drawing. On the
Oh
surface,
yeah,
it's
it
looking
does.
really nice,
Right.
right?
Yeah.
It got all section views, got detail views, all holes are properly lined up and everything. And now, what I'm gonna do is I'm gonna just run it through my check. So this is a drawing checker, which basically obviously lives in your desktop, um, and you can upload PDF. So
Yeah.
let me upload this. All you do is just drag and drop the
Okay.
PDF in this file in here. So just drag and drop PDF.
Okay.
Let me just move this here. And then it runs the process. And let me just move us around as well. And there you go. So it came up with central board with the counter board. So the depth, so it just came up with this, that it's not manufacturable because so we got the diameter of the bore, but we haven't got the depth, how deep we need to go for this diameter, right?
Hmm.
So it picked up that obviously without this, without the depth of the bore, it will come back from the manufacturing or production and it's emails back and forth like what's missing in this thing. The other thing, and then it also sets up the priority. The priority should be high, which medium, fair enough, okay. And
Okay.
then
Wait.
these two are low. To manufacture this part, we need the depth of how deep we need to go for this diameter, right?
Oh, and the depth is not.
The depth is
Oh,
not
I
there,
see.
right?
I see. The depth is
They're
only to
missing.
that protrusion. It's not to the.
Yes, exactly. It's not to
Yes.
that thing. So they don't know how deep they need to go.
Okay.
So that's what it picks up. And also, like, if it gives good feedback, you can train it, right? So you can thumbs up means obviously, and then
Hmm.
also if it messes up, you do give thumb down. Where we have like a knowledge graph, and you can just give it feedback, like, look, you messed up. We don't need the depth. The depth is on this section. So the next time it runs, it knows like might need to look at other things as well.
Okay.
Because majority of the things what's happening in companies are like, so this company, let's say this is a valve manufacturer, they're making hundreds of valves every day, right?
Hmm.
Majority of the drawings are more or less the same. So that's another really good use case for this AI. That it
Okay.
checks.
Okay. Right. So, and you
Uh,
respond to it in natural language, just like
you respond to it in
ChatGPT?
the natural
Okay.
language. You can give it feedback, like, look, give me the feedback. Like if it messes up, then you can give it feedback in natural language, and then all that feedback gets collected, and
Hmm.
we give company access to kind of modify their knowledge graph as well. Because what you don't want is people like junior engineers, especially, uploading different stuff, which is then it becomes garbage in, garbage out kind of situation, right? So we
Right.
gave like access to the admins, so they can manage all these things, and also the rule set. So what is it looking for? Like some companies will look for different stuff, some company will look for different stuff. So I can show you actually. Let me
Okay.
just see if I can show you.
So it's learning from my drawings,
It's
and
learning from your
it's
drawings, yes.
it's getting smarter and smarter. What is it? What is it coming in with initially? What have you a
So we
library
so
of drawings that
yeah,
you're
yeah. So
trained
we
on?
so when we started, we had like 10,000 drawings that
Hmm.
we kind of trained the model on.
Hmm.
Um, so that's kind of our base.
Where'd you find them? Is that a common database?
It's not common database, and this is another thing, like looking backwards. So because I spent 10-15 years in engineering, I was collecting all this like random drawings, or I had in my folder for this company, blah blah blah. So I had like loads of drawings done anyway,
Okay,
and so I never knew that I'll use these drawings. But you
I
know
see. Yeah,
so
yeah, they came in handy.
they came in pretty handy, right? So,
Yeah, yeah.
and at the back end, right, so you can set up all these rules for whatever you want. So let's say if you are you're checking machining part. So this is the part
Hmm.
that I ran, and all these were turned on. It will check for tolerances, GD and T. It will see if the fits and limits are verified or not, thread specification.
Hmm.
It can look for sheet metal, various stuff, like in assembly, what do you want to check?
Right.
Um, so, and then also again, do you want to comply with all these? So these are pretty standard, like industry standard that. Uh, so, like, for example, in the UK we use BS 8888, which is, you know, do you want that turned on? And similar for, like, we have for US customers, ASME 14.1. Do you want to check your drawing against that? It depends on the industry. That's why we kind of made it so customized, so
Hmm.
everybody can, so it works for basically everybody. And also what we have as well, so you can upload your own internal company documents, and then it kind of collects all the rules from your own company document, and then it applies. When it checks the drawing, it knows that these are your company rules. I'm going to check against these first, and
I
then I will
see.
go to our NexCAD model.
Okay. Okay.
So
So I'm impressed I can recognize features like holes. Uh, Now, is it also able to check one view against another it doesn't have a model, but is it
yeah, yeah,
somehow?
it checks against your views. It checks all the dimensions.
Hmm.
It can read all the dimension. It can read your bill of materials, um, and it can also read if a flag is like dangling in the, if you put a bill of material item but you haven't ballooned in the assembly, right? So this is pretty
Hmm.
common mistakes that people do. Or the balloon is like hanging in the air, so we don't know which it's referring to in the assembly. So all
Yeah,
these little things, because I mean, the good thing is, because of my experience, I knew all these kind of mistakes
yeah.
or general mistakes that people do. And when I show, I mean, it's very easy for me to kind of sell the product as well, because when I showed, or when I talk to the engineers, especially if they are on the call, they know, right? Oh yeah, yeah, we know this, right? And we want this, so it's a easy sell for me then.
Right, right. I understand that it's doing a seems to be doing a good job of checking annotation, but does it also check geometry? If I was missing a dashed line that showed a hidden edge, uh, would it does it know to would it call out that you're missing a hidden line here?
For PDFs, I don't think it does.
Hmm.
But that's why we have the CAD integration. So let's say if so, this checker runs uh, with CAD as well, right? So
Okay.
let's say I have this drawing, right?
Okay.
Uh, Let me just bring that and that other the checker face to face. Right. So let's say now it's connected to CAD, and it says inventor connected on the bottom. Um, so then we can read a lot more data. And if I go to the drawing checker now, so now it's checking the drawing against this um, in inventor, right? So it's not checking that PDF.
Okay.
It's
Okay.
automatically detected that the inventor is open. I will check against inventor file, whatever is open.
Oh, okay.
And
So now you're
here
checking
we can
against the
read,
3D
yeah,
model.
we can read if somebody hand typed the dimension, if they hidden a feature or if they hidden something. Um, so look at this hidden dimension value on sheet, right? So it's picking up, there's a hidden dimension on the sheet, right? So if you were a checker, you won't know that there's a hidden dimension, but
Right.
because this picks up and it points me to the dimension that's been hidden.
Okay.
Oh, look at this height value, they hand typed it, right? So all these little things which we can read. So with PDF, it works really good. That does
Yeah.
like 80% of the job. But if you want really good output, then yeah, we have CAD integration for Inventor and SolidWorks, and it can reach a lot more metadata. And then the idea is obviously we go to 3D model as well, so it can give
Hmm.
you, if
Hmm.
you're, let's say, for plastic injection molding, your draft angle is not right, or
Yeah.
you're just gonna have shrinkage, wrappage, whatever.
That's, I
Um,
have to say that's pretty smart that you could integrate with Inventor and with SolidWorks too, correct?
exactly, yes. Inventor
Yeah,
and
yeah.
SolidWorks we can do, um,
Okay.
and
Now,
and
as
hopefully.
you, I'm thinking that on your wall somewhere you have like a, like a temperature chart, only not, it's not temperature you're detecting. You're saying what percentage of the drawing that you can check. What are you up to? Are you up to like 90%? You could
Or
save
from
90% of
evaluation,
the,
like evals perspective, yeah,
yeah.
I think we quite good. I wouldn't say like, I think if I were to put like A drawings 80%,
Hmm.
it does pick up 80% of the mistakes.
Okay.
Um, and obviously with design intent, it's not gonna pick up the design intent. Like let's say why you made the shaft 10 millimeter,
Hmm.
right? You could have
Right.
made this unless it
Yeah.
has the context of the whole assembly.
Yeah.
Um, but we are obviously working towards that as well, that you can read the whole assembly in the whole stack and then make design decision as well, or give
Hmm.
feedback on the design decision. um, so we
Okay.
started, like, to be honest, this checker we started working on like 4 months ago, so we made quite good progress to be
Uh-huh.
honest.
Yeah. Yeah. No,
Yeah,
that's
there's a
excellent
lot.
progress.
The roadmap is quite big. Like, I want to kind of make it so good that it becomes the industry default.
Yeah, I imagine eventually you want to have the not just suggest the changes, but actually make the changes inside the CAD model, right?
Yes, true, true. So we have a feature where it fixes the dimensions for you. So it
Hmm.
suggests the tolerance and it fixes for you.
Hmm.
It puts datum as well for you. But then again, it needs to be connected to the CAD software to do all that, because we're calling bunch of APIs
Right.
to do that, right? So
Okay. Okay.
we already have that functionality, and we're kind of testing it. To be honest, it's like we haven't gave it to the customer because then they will. I don't want to kind of tell them this yet, but you know.
Yeah.
I want to show you the other thing that we are working on as well.
Hmm.
So let's say this is we are releasing in Q1, mid Q1 maybe, which is basically I was saying, like, look, we don't need to create the drawing. So this is like your drawing creator basically. So all I have to do is just say to it, or just click a button which basically says to the AI to create a drawing for me,
Hmm.
and then it looks for. And this is still in work in progress, so don't take it like, it's a finished
Yeah.
product. But what I'm trying to show you is that, look, this the roadmap we are following is like, yes, we want to eliminate the drawings, then we want to eliminate even the 3D modeling, so engineers are like making high level decisions.
Oh, I see. I see. Very good. Very good. Hey, you might be interested in this, but I just read about MIT is taking videos. They call it video CAD, and they're taking videos of drawing creation. They're using Onshape, but they have 41,000 videos that can be used to train your AI on.
Okay. Oh wow. Okay. And
Yeah,
yeah, like definitely interested if we can get hold of those videos, that's pretty awesome.
that could
And
be
look at this
useful to
drawing,
you.
right? Look at
Yeah,
this drawing, right? So
yeah.
it knew where to put the section.
Hmm.
It also put like your GD&T, your tolerances. So even to find this tolerance, I need to go and find, because it's a circlip, a functioning part. I need to go find in the supplier data set what's the tolerance. It automatically put the tolerance for me. And then again, it kind of knew that it's a shaft, which obviously something's going to go on it. So let's put H7. on the tolerance. Pretty standard. Again, you can change all these. Um,
Mhm.
Again here, like it still messes up. Like it kind of dimensioned it twice, so you can make one reference, or you know you're making some decisions on your end. But to start off, it does pretty good job. So I mean,
Yeah.
as an engineer, I would look, yeah, man, this drawing looks complete. Everything is properly dimensioned, properly spaced.
Uh-huh.
GD&T there. It missed the datums for some reason, but
That's
all
the
the
data.
tolerances are there.
I see its dimension to a part of it's the on the end view, it's dimension to the
From
outside the diameter where there wouldn't be any material. It's over
exactly,
dimensioned. It has dimension
it
from the center and it's
yeah,
dimension from the outside where you couldn't measure it.
yeah, you're right. So
Yeah.
that's why we need to make. So this is where, like, obviously engineer needs to kind of come in and say, look, make this dimension uh, from the end, and then
Mhm.
make this. If you want to leave it for reference.
Right.
So but
Yeah.
they're gonna take this dimension as the driving dimension.
Yeah. Yeah. Well, I would have
You
loved
know.
to have this. Where were you when I was using uh, making
uh,
drawings?
I would love to have this in like last 10 years of my life as well. Especially the
And-
checker, because as a junior engineer,
yeah.
you would love the checker, right? So because it's picking up all the mistakes,
Yeah.
giving you suggestions on tolerances and all that. So
Uh-huh. Okay, so
it gives.
does it, are you are the third party program for Inventor and SolidWorks that they're
We are standalone software.
standalone? Okay.
Yeah, and we obviously connect with these CAD softwares. We plan
Okay.
to do it for Onshape as well. I mean, yeah, this is one of the. I think it's quite good now. Onshape. When I used to, like, because I travel a lot, and like with manufacturing companies, I got loads of connections, and
Mhm.
people were not used to, or were not even open to Onshape, because they didn't even consider it serious enough. So it was NX, Inventor, SolidWorks.
Mhm.
But now I can see the shift. Like, people are using Onshape. So it's the right player. I think the right player is emerging as well now.
Yeah. As a user, let's say I'm using SolidWorks, then do I just send you the file? It's the drawing
No,
file, or do I send you the model and then your service will come back with corrections? Is that how it
yes.
works?
So yeah, that's exactly how it works. So
Mhm.
when you open a drawing in your SolidWorks, and you have our software open, it will automatically detect that SolidWorks is open and a drawing is open.
Okay.
And then if you press run checker, then it will check against whatever is open.
I see. I see. Okay. So it can interface very neatly, it seems.
Or it's very seamless interface. Yes, you won't even, and even seamless onboarding as well. It's just an exe file. You put your configuration key. Pretty smooth.
I don't even have to exit my part or my
You don't
assembly.
have to exit. You don't have to exit your part. And once you run the checker, you can go and do other things as well in your CAD software. You don't have to wait for the checker to finish its check, and you
Okay.
can run multiple times. So open one drawing, run the check, batch it, run the check. Whatever you want to do.
How's your pricing model work? How do you charge for it? Do you charge per attempt or is it all you can eat?
And
Menu?
it's all you can eat, but we charge setup fees, because obviously this is not for like very small companies.
Hmm.
So it needs to be team of five and above. But we
Hmm.
charge a setup fees where we kind of understand their checks, what they want to check against, and then we, on the back end, we kind of prepare the software for them so they can extract the maximum value out of it. So we charge a setup fees, and then after that it's subscription. Like,
Got it. Got it. And it's all done with AI. You don't have a bunch of your old buddies from Pakistan checking it.
oh yeah, no.
For the uninitiated, tell me how it would work with AI because you've trained it and it sort of understands procedures and standards, ISO, ASME, uh, ANSI. Uh, so it's got a knowledge of that and it can apply that. But do you also have rules-based checking? Like if this, then that? Is that
Yeah, yeah,
also built in?
definitely. Yeah, yeah, yeah.
Yeah.
We're trying to. Our first priority is we check as many checks we can do with using CAD APIs, right?
Okay.
So again, it costs us less than giving everything. The response time is very less again. So our first priority is checking against these things. Like let's say, for example, if I put my this dimension across here, then
Hmm.
that's like a violation, right? Of because one dimension is going to the another view. This we can do with API calls, right? Bunch of algorithm, clever algorithm to detect all that. You don't need
Right,
AI for that, right?
right.
Um, so all that we can extract from CAD APIs. And like I said, AI we are using like maybe 20 to 30% uh, just for reasoning on some parts that obviously we can't do without with the CAD APIs.
Hmm. Hmm. Very interesting.
And then on the PDF side, because obviously there's no more like calls from APIs on CAD software. So then we have our own OCRs algorithms, segmentation algorithms that we are extracting the same information or trying to extract the same information.
I see. Okay. So, okay, we'll work with my models. We already discussed this. I'll work with my models. I can also send PDFs for to be checked. You would, of course, value the model itself uh, because it's more checkable. You could more accurately check it and guarantee more of a better result. Um, is there a different price then for each? Or you said it's all you can eat, but do you have two different prices for PDF checking or for model checking?
No, I think the we kept it really simple for
Mm.
so obviously we just launched like 2 months ago, so we
Mhm.
we're still figuring out with the price,
Okay.
but we're trying to keep it so that people on board with us and then they start using us, give us feedback so we can improve the product, right? So this is our main
Right.
goal, but we don't want to distribute it for free because then, like you said, no skin in the
Yeah.
game.
No skin in the game. Yeah, everyone will say, "Oh, it doesn't work," and yeah, they say free software is worth what you pay for it. Right. So you don't want to be in that on that uh, doing that, but also you don't want to price it so high that the engineer has to ask his boss for money, right? They can try it themselves if they want to.
Uh, yeah, true. Yeah, that's one of the things that we're kind of figuring out how to give
Yeah,
access
yeah.
to individual engineers.
Hmm.
Because at the moment the way we set up is going through the boss and then they buying the software and then distributing it among their engineers
Right.
uh, because of the setup fees, which is obviously a bit pricier. But we are still very kind of competitive with our competitors on
Uh-huh.
pricing. uh, Again, because we don't want to price too high that we're not in the
Yeah,
race, and
yeah,
we don't want to price too low that they think, oh, this doesn't work or you are too cheap.
yeah.
you know
Do,
so
do you want to say on the air what your prices are? Or do you want people to check your site for that since it might be
I,
changing?
yeah, I want to not mention the price because we are still figuring out the price.
Yeah,
And you book a demo, the sale process, you book a demo and then we show you, we understand
yeah.
your problem, and then we can price it up for you.
That makes sense. Tell me how you're getting the word out. I think I saw you first on LinkedIn, but are you using any other methods?
um no, to be honest, it's more like LinkedIn and my personal
Mhm.
brand, and my past connections. So far all the companies that onboarded were like more like, okay, yeah, we know that he does good job, let's see what he's up to, you know so we're not going heavy on the marketing yet,
Okay.
but maybe next year we'll try to go heavy on the marketing side.
Yeah, next year. I have to say, once you can make a great product, and there's a lot of smart engineers that have good products, and I'm seeing quite a few of them right now. But it'll come to a point where marketing will take over
True.
as the main driver for success. Once you have a great product, it's fairly bulletproof, and now you just need to get the word out. Um, I always point to SolidWorks as a best example of marketing. They had a great product, but they were in a market where they were competing with IronCAD and Inventor. Later on, it was Inventor, but they just blew everybody away because their marketing was so good. You could even say that all the MCAD products were similar. One was even better than SolidWorks, but it didn't matter. The marketing uh, made everything
Yeah.
happen for them. So, but anyhow, that's down the road. I have to congratulate you on already making revenue, uh, which is very most startups don't want to. Some would even tell you they don't want to make any revenue yet. They just want to grow the market. But I don't know if that's very
I,
sustainable.
yeah, I want to make revenue, want to make stable company, right? Because I'm
Yeah,
thinking like long term as well. So I'm not too kind of constrained by any investor or anything. And
yeah,
that's my philosophy. I mean, obviously, I can disagree with other people's
yeah.
way of
So is
thinking.
there the company's all yours now, 100% ownership? How many people?
Yes, yes, 100% ownership,
Uh,
four people.
uh, four people. And
Yeah.
all in London or distributed?
I not distributed.
Yeah, okay, okay.
And
Yeah.
not can't afford London yet for some
Oh,
reason.
okay, all right. Right. But you do the it sounds like you do the bulk of the development and programming
Yeah,
then. Okay.
yeah. I mean, I do. I got very good developer as well, which I was working for like last 2 3 years.
Hmm.
So the core team is pretty solid. And yeah, like you said, marketing the first. I joke around this, but I think this is going to be true. The first hire, official hire, is going to be a video editor or
Oh,
video
okay.
storyteller or something like that.
Yeah, yeah, yeah. Okay. Yeah, you're that's good. Yeah. Same thing. Same thing. I think my quality of my video and audio is not up to par with is not up to my standards in engineering. That's for sure. I like what I saw. I wish you the best success. Before I go away, I'll give you uh, one thing I've noticed, or one thing I'm hoping for, is that there will be a program, AI, that'll help you just design no matter what software you're using, right? It's just like
Mm,
I want to make a shaft, and it'll if you're using SolidWorks, it'll put in the right commands for SolidWorks to make that shaft. You know, it'll interact with you. It'll say, "Oh, how big do you want to make it? How long? What diameter?" Right? But it'll then produce the commands that the software understands. Because I'll tell you, I know a lot of software programs, but each time I have to look up the command to do it. And I wish there was something that would just be sort of program agnostic, right?
mm,
That there'd just be natural language interface to whatever I'm using. It could be Onshape, maybe it's Inventor, maybe tomorrow it's SketchUp because I'm doing something in AEC, right? Oh my God,
yeah,
that's a lot of commands to store in my head. My head's not good at that, right? I
yeah.
want AI help. I say, no, just like you're helping people with drawings. It's like AI, you figure it out. You figure it out.
You figured that
You read everything, you remember everything. Read all the damn documentation and tell me what commands are in there. And by the way, put those commands in, right? So that's
No, I
my
agree. I agree. No,
yeah,
I think I would like to take it a step further and we
yeah,
say, look, we don't even need the CAD software, right? The future.
yeah,
In the future, why would you
yeah.
need a CAD software, right? If AI
You're
is doing
right. You're
everything.
right. Absolutely. Take it all the way to the end. Put it. We say under the
Exactly.
hood in our country. You say under the bonnet, probably, right?
Yeah,
So
exactly.
okay, put it under the hood. I
We
just want to steer the car, right? I
exactly.
don't care how the engine does it, right?
Exactly.
Give me that high
Exactly.
level control. I want to be an engineer. I want to be creative, right? I don't want to get lost in, oh, look up what command this is in Inventor to do this, right? That's too
Exactly.
much. It's
That's
a
that's the
roadblock.
future. That's the future I want to build. Like I
Yeah,
said, you don't need CAD. You don't need all these drawing creation, drafting, blah blah blah.
yeah,
You make high level decisions. Why this material? Why that thickness? What's the physics behind it?
yeah,
If we change this, what happens?
yeah.
Why things break? Just and if I'm happy, approve, send it to manufacturing or send it to a robot who's you know.
Right. Yeah. And by the way, if we're going to do it for design, we should do it for simulation too, because
Oh,
like,
definitely, definitely.
yeah,
Simulation is a big piece,
yeah,
and I think pretty decent companies like Antop they're working on it.
yeah,
We need speed of like as an engineer, I want if I'm making a design decision, I want quick simulation or like not preparing the model, giving it to another guy who's expert in simulation, and then he takes 3 days. No way, man. Because I'm an engineer, I'm gonna make the design decision, right? I
yeah.
want answer quick on that thing.
Right, exactly. Well, all right, good work. Good work. I expect great things. I'll let you go. You're not making any money talking to me, but it was great,
No,
a
no, I
lot of
love it. I
fun.
mean,
Thanks for showing it to me.
yeah.
Thank you again for joining me.
Yes.
See you.
Thank you very much.
Thank you. Bye bye.
Cheers. Bye. Bye.
Thank you for listening to FODES, the Future of Design and Engineering Software show, brought to you by Eng Technica. I hope you have learned of a new application or technology that will help you with your job. If you have an application you think would be of interest to other engineers, please let me know by emailing me at rupinder@engtechnica.com or message me on LinkedIn.